The addition rule tends to appear on formula sheets. I think it is on the, yes, it is. I can see it right here on my desk. It's on the Year 12 Methods exam, and it's written as follows. The probability of A union B is the same as the probability of A plus the probability of B, take away the probability of A intersect B. And I've always wondered why they put that on the formula sheet, because it couldn't be more intuitive. Okay, so hopefully throughout this lesson, what I can show you is the reason why the addition rule exists, and hopefully you're able to write it yourself from here in. All right, so when two events are considered, the addition rule connects the probabilities for different outcomes. So here we've got the A union B. So that's what that is. A union B is equal to the probability of A. So we're going to take the probability of A plus the probability of B, and what we're going to remove is one lot of the intersection. Why? We'll have a look at what happens when I add the two together. When I add the probability of A, I add the elements in A and the intersection, so I add this part here. And then when I add B, I add B only, and I add the intersection again. Okay, and the truth be told, we only want one lot of the intersection. I don't want to add it to equal that and then add another bit, because that wouldn't be a true statement. So essentially, all I want to do is add A only, B only, and one lot of the intersection. But a great way of doing it is just adding A and B together and then just removing one lot of the intersection. We can also do it via the number of elements. So if I'm not using probabilities but numbers of elements, then I can use the same formula but just change the probability to the number of elements. When we've got mutually exclusive events, and that is a situation where if I said my musical taste is mutually exclusive to yours, what I'm implying is that A intersect B is null. Girls, I'm afraid we have nothing in common in terms of our music taste, and that's what it would look like. All of my music here, all of your music there, and all the music in the world outside of that, or in the school, depends on what the universal set is. All right, so that's what it would look like. There's no overlap. Remember what I said, if we tried to find a song that would suit both parties, we're not going to be able to find it. So if A and B are mutually exclusive, then A intersect B is equal to 0. And in that case, what we could do is just add the probability of A and the probability of B together. We don't need to remove one lot of the intersection because we'd be removing nothing. All right, this Venn diagram shows a group of 15 people and whether they like apples or bananas. What is the probability that a random person picked likes apples? What's the probability of A? Well, that's going to be 10 out of, what is it, 6, 10, 15. Don't forget to simplify. All right, what's the person that they like bananas? What's the probability, not the person? What's the probability that a random person likes bananas? Well, we've got 9 out of 15 equals 3 out of 5. What's the probability that a person picked likes apples or bananas? Okay, so probability of A union B. Well, that's going to be the same thing as 6, 4, 10, 15. It's going to be 15 out of 15 or 1. It's guaranteed that they like apples or bananas. Is this the same as probability of A and the probability of B? So if we did the probability of A plus the probability of B, surely we'd get it all together. Well, let's try it out. We've got 10 on 15, or 2/3, plus 9 on 15, which is equal to 19 on 15. Okay, and you can see there that that can't happen. 1, we've got a probability larger than 1. Okay, and 2, it doesn't equal the same thing that we just found out. Now, what's gone wrong? Don't I need, if I need to work out the probability of A plus the probability of B, or this thing here, probability of A or B, what I need to do is remove one lot of the intersection, or the middle part here. So the answer to this is no, it's not. Okay, must remove 4 out of 15 from 19 out of 15 to equal 1. Okay, so 4 take away, or 4 out of 15 removed from 19 out of 15 is 15 out of 15, or 1. Okay, so again, be careful about assuming that you get all of these together, or you get the probability of A or B by simply just going 6 plus 4 plus 5 and double counting the probability of A and the probability of B. You'll double count that intersection there. Right, card is selected from a pack of 52 playing cards. 4 suits, no jokers. Let A be the event the card is a diamond. Okay, now you need to know a few things about cards. That there's 52 cards in a deck. There's 4 suits. There's spades, there's diamonds, there's clubs, and there is hearts. There's 13 of each suit. All right. Yeah, so that's the basic construction of a standard card deck. If you haven't played blackjack before, I highly advocate that game. It's very mathematical, notwithstanding the fact that it is a fun game to play. So check that one out. All right, so let event A be the event the card is a diamond. Well, there's 13 diamonds, okay? And let B be the event the card is a jack. So within these 13 cards in each of these suits, there's going to be a jack of each suit. So there's a jack of spades, jack of diamonds, jack of clubs, and jack of hearts, okay? So B be the event the card is jack, there's 4 jacks. Right, so let's have a look at the Venn diagram. So event A is the card is a diamond. Event B, the card is a jack. What we're going to do is take care of the intersection first. What do these two things, or these two events, have in common? The jack of diamonds. There's 1 jack of diamonds. There's 13 diamonds in total, so that is going to be 12 left over there. So we've got event A, the card is a diamond, 12 plus 1. 13 diamonds. There they are there. All right, the card is a jack. Well, there's 3 jacks left over in addition to the jack of diamonds. All right, and what we've got left over here, girls, is the remaining cards in the deck. So I've got 13, 16. I'm going to do 52, take away 16, which is 42, 36. All right, let's slam that into a two-way table. So A and B is 1, A and not B is A only, which is 12, B and not A is B only, which is 3, neither A nor B is 36. Let's start doing some totals. 39, 4, 36, 46, 48, 4 and 48 is 52, 39, 49, 52. Everything checks out there. What's the probability that the card you pick is a diamond or a jack? So diamond or a jack is going to be either, so we've got probability diamond or jack. So shouldn't use my own, it's A or B, diamond or jack, which is going to be those ones there, which is 13, 16, out of 52. You can also pick it off the two-way table by doing those ones there. So it's all of those ones there that is or it's not that one, not 36 is the other way to do that. Let's simplify that fraction. So that's 8 on mental blank here, 2, 6, 26. 4 over 13. What's the probability that the card is a jack or not diamond? Probability that it is a jack or not diamond, not A. So that's the probability that it is not A or B. All right, so what does this one represent? Well, to be honest, I really don't know. Okay, and how am I going to find out? Let's go and shade the Venn. Okay, so the first thing I'm going to do is shade not A, which is that and that. That's not A. And then I'm going to shade B, which is this part here, as well as this part. Now notice I didn't switch color because I've got a union or an or here, which means we don't care whether it is shaded once or twice, we only care whether it's shaded. All right, so this statement actually is the equivalent to the probability of A only, not. Okay, so it's not A only, so what we're going to do is remove 12 from 52. Okay, so where that's 42, that's 40 out of 52, 20 on 26, 10 out of 13. Okay, so again, in that case, at 39, 40, oh, look, they would probably be easier to add together than subtracting off 52, to be honest, but it shows you that you get the same answer either way. All right, now how does the addition rule apply to this scenario here? So if we were doing this, what we're going to do now is use the addition rule to get these values. So the probability that you pick is a jack or a diamond. So probability of A union B is the same as the probability of A plus the probability of B, take away the probability of A intersect B. That's the addition rule. So what we're going to do is work out the probability of A, which is 13 out of 52, plus the probability of B, which is 4 out of 52. And from that, we're going to remove probability of A intersect B, which is 1 out of 52. Now let's work that out. We've got 17, 16. 16 out of 52, which is equal to 8 out of 26, which is equal to 4 in 13. Notice how we got exactly the same answer, okay? So we can use the addition rule to get that quite easily, or we could use these pictures or Venn diagrams or two-way tables to get exactly the same answer. And that's why I say there that the addition rule is nothing fancy. It's the formalization of what you're kind of doing already. Now, how would we use the addition rule on this? Okay, so if we had the probability that A intersect A, not A, union B, we can write the addition rule as a modified addition rule. We're going to write this as the probability of not A plus the probability of B, take away the probability of not A intersect B. So notice what I've done there is I've essentially just changed the addition rule. So instead of having A, B, and A and B, I've just put nots on all the A's because that's how it's constructed there. So I've manipulated the rule to kind of suit me. Okay, now what's not A? Not A is all of this stuff out here. That's going to be 36, that's going to be 39 out of 52, plus B, which is going to be 4 out of 52, take away the intersection. Ooh, I can see I'm about to get something wrong here. 39, 43, take away not A and B. No, I'm not going to get it wrong. Not A and B is B only, which is take away 3 in 52, which is equal to 39, 40 out of 52, which is equal to, as we found out earlier, 10 over 13. Interesting. I reckon the addition rule is harder to use for that problem than it is just using the picture. But anyway, there's another application of the addition rule. I can use it to work that out, but I need the picture in the first place to work out what I'm after there. And if you're using the picture, why not just answer it like so? Anyway, there is your work 8C. So get stuck into that, girls.